Welcome back to The Explainer. Today, we're diving into a hypothetical scenario from our source material that is as thrilling as it is, well, totally terrifying. We all know the universe is packed with wild mysteries, but what would actually happen if the absolute most constant thing in our daily lives just changed overnight? What if our sun suddenly became a sapphire star? It's an absolutely fascinating look into cosmic astrophysics, and I am so pumped to walk you through the data. Let's get right to it.
Okay, let's dive into this. I really want you to imagine this for a second. You wake up tomorrow morning, you look out your bedroom window, and instead of that familiar, warm, golden light pouring in, the entire world is bathed in this harsh, piercing blue. The sunrise isn't yellow anymore. It's a completely alien neon blue. It would feel incredibly strange, super mysterious, and as we're going to see from the data today, incredibly dangerous.
So, Section 1. A sudden blue sun. Baseline reality.
To really grasp how catastrophic this change would be, we've got to establish our baseline first. Now, you might be wondering, what color is the sun right now? From down here on Earth, our atmosphere scatters the light, which makes the sun look yellow to us. But if you were to float in a spaceship just outside our atmosphere, its true color is actually pure white. This is a really vital baseline to keep in mind, because out in the universe, a star's color isn't just for show. It tells us exactly what kind of energy it's putting out.
Which brings us to Section 2, the science of blue stars, astrophysics.
So what exactly does a blue sun even mean? Well, our sources define a blue star pretty simply. It's a massive star with a significantly higher surface temperature than a yellow star, releasing vastly more energy and radiation. You see, a star's color isn't just some random cosmic aesthetic choice. It's a direct, screaming indicator of its immense heat. Basically, blue means hot, like incredibly hot.
Now, what's really interesting about this slide is the sheer scale of the difference we're looking at here. It's mind-blowing. When we compare our current yellow star to a blue star, the relative temperature and the energy output just absolutely skyrocket. We are definitely not talking about a slightly warmer summer day here. A blue star operates at temperatures that literally dwarf our current sun. It pumps out energy and cosmic radiation at levels that completely rewrite the rules for anything unlucky enough to be in its path.
All right, Section 3. A world burning down. Immediate changes.
If this cosmic shift actually happened tomorrow, here is the rapid timeline of immediate, inescapable changes that would kick off the very morning the sun shifts. Step 1. The sky color shifts drastically. Our atmosphere would just be completely overwhelmed by this massive new spectrum of light. Step 2. The sunlight intensifies immediately. It wouldn't just be a bit brighter, the glare would be literally blinding. And Step 3. Global temperatures start spiking rapidly. We're not talking about gradual climate change over decades here, right? This is a sudden, extreme thermal shock hitting the entire globe all at exactly the same time.
So, what does that actually mean for us biologically? Well, the human impact is, to put it mildly, devastating. We're looking at incredibly dangerous heat and radiation levels right off the bat. We would experience severe skin and eye problems almost the second we were exposed to this new light. Essentially, you're looking at a total inability to survive outdoors. Just stepping outside your front door to check the mail would very quickly become a completely lethal endeavor. But of course, we humans aren't the only ones taking a hit. The impact on nature means our delicate ecosystems would simply crumble under the stress. Plants, which, are perfectly adapted to our current sunlight, would totally struggle and fail to adapt to this intense new energy. The oceans, taking the brunt of absorbing all that excess heat, would begin rapidly warming, and animals would become severely stressed and confused, their natural biological rhythms just completely shattered by the harsh blue glare and the violently spiking heat.
So, the crucial point is that even if we try to just hide indoors, our modern world still falls apart completely. The massive spike in stronger radiation would straight up fry satellites and electronics. We'd see catastrophic power system failures as the electrical grid just completely overloads. And naturally, this leads straight to global communication blackouts. Our entire modern infrastructure would be instantly overwhelmed by the barrage of cosmic radiation released by the blue star.
Now, our sources point out a pretty grim irony in all of this. On one hand, we have these theoretical advantages, like potentially limitless solar energy from the stronger sunlight and incredibly bright skies. But unfortunately, those theoretical benefits are instantly canceled out by the actual dangers. We're talking extreme heat, lethal radiation, and total climate collapse. I mean, all that limitless energy really doesn't help us much when there's no infrastructure or, biosphere left to actually capture it.
Moving to our final section, Section 4. Could Earth survive? The ultimate verdict.
The absolute core truth of this entire explanator really just boils down to cosmic balance. Earth's survival relies entirely on the precise, delicate balance of energy provided by our current sun. We are so perfectly tuned to our specific white-yellow star. Our distance from it, the makeup of our atmosphere, our biology, literally everything on Earth is calibrated to the exact amount of energy our sun produces right now. That delicate balance is the only reason life even gets to exist here.
And this brilliantly illustrates a direct conclusion from our source material, which states a hotter blue sun may make Earth completely unlivable. It's a short, simple conclusion, but wow, it carries the weight of total destruction. There's absolutely no adaptation fast enough to save our planet from a cosmic change of this magnitude. Which leaves us with this final, lingering thought to wrap up today's explainer. Think about it. If even a tiny cosmic change, just a single shift in the temperature and color of our star, can transform Earth so completely and destroy us so rapidly, just how fragile is our existence in this massive universe? It really makes you appreciate that warm yellow sunrise, doesn't it? Thank you so much for joining me for this focused look at the data. Keep asking these massive cosmic questions, and I will see you in the next explainer.